All right, so as a reminder, please put away anything you're doing that is not math. Please put away anything that you're so close to the end of the book. I wish you could finish, but I have to ask you to put it away now. I wish I could let you finish. All right, people in the back of the room, Bear, you have about 5 seconds to figure out that I've been trying to start class for the past 30 seconds, or you need to relocate yourself. Because right now, I have very little confidence that you will make it the whole class period back there. As you were just actively ignoring the teacher at the front of the room making announcements. If you were missing homeworks, they went into math without effort grades. So if I made a mistake, we could figure that out and take care of it together. And if you just goofed and forgot to turn them in, or your papers were on the no-name board, it gave you a tiny bit of leeway, but they're in math. So if you have not checked math like yesterday or today, you might have a missing in there. That you owe me.
How early today? Because I checked it like
yesterday. I updated math yesterday. I have not done these since yesterday because I worked last night, right? Monday nights, I go to my other job. I don't normally get schoolwork done. I will tonight. So, I had something else. Oh, homework has changed to yellow, indicating to you we're switching back into colors. I'm trying to get ahead of you guys. So, hopefully this next set will be yellow, but all of the ones prior to 924 are grouped. So, turn those in whenever you're done with all the white ones. They should be done by tomorrow, which means I will tell you you have to turn them in Thursday, and then if history repeats itself, I won't get math actually updated, and really if you get them to me by Friday, you'll be safe. I mean, if we're being honest, like that's what will happen. I'll ask for them Wednesday, I'll tell you have to give them to me Thursday, and I'll probably put them in math over the weekend, if I actually get on it. And then Liam will turn them in with a no name. They'll end up on the chalkboard. He will write his name on them, but then put them back in his binder, forgetting to actually have me update the grade. This truly happened. I'm not just like making stuff up. That was the funniest, probably when people are like, what do middle schoolers do that surprises you? Like, think that when they took their paper off a chalkboard, somehow their grade magically changed and stuck it in their binder. That's one of those things.
Or if you take it off the name board, the name doesn't go on it.
Yes, when I turned it in again with no name. No, I can't tell. Like, certain handwriting, like, I know Logan's handwriting at this point. I probably could guess your handwriting, but a lot of you guys write very similarly numbers. Alright, so, time to dive in to a really weird topic. Real numbers. As opposed to, like, fake. As opposed to, like my imaginary friend that I've had since I was 3. Like, what do... Hey, the 8 people talking at the same time right now, you're all being rude. So, now finally someone raised their hand to contribute an idea, but this doesn't work if everyone just talks whenever they feel like it. Right? Real numbers, I will start the conversation, is a poo-poo name for this. Because it makes you feel like the other ones are like fake, right? Or like what we actually call them is imaginary, and that's an even worse name. Henry, thoughts as we dive in?
Okay, what was your imaginary friend's name?
Oh, I don't remember. I just always joke that I still have an imaginary friend, but I don't. I just talk to myself. At some point when you're an adult, you just admit that you're talking to yourself, not an imaginary friend.
I was just joking around.
Oh, I'm sure I had an imaginary friend, though. I mean, did you? I'm sure I did. Or, well, I had older siblings, so maybe not. So, real numbers. And this is defined on your paper. So go ahead and put your eyes on the yellow paper. Are broken up into 2 different categories. This is what often confuses people. They get imaginary numbers mixed up with irrational. Irrational numbers, they are real. They are part of the real number system. So please, right now, understand irrational does not mean imaginary. Those are two totally different classifications. Ear is a stem that you've had. At least I hope. Have you had ear?
Don't think so.
Aha! Now I get to give you another list 3 stem. If you are being irrational or irresponsible, or when people make up this word called irregardless, which is not a word, what does ear mean when you put it in front of a word? Patrick? Not! So, not rational.
There are way too many stems for not.
So, rational, please underline, highlight, or circle, do whatever you want to indicate. Where is it? Where is it? Where is it?
Is this on our yellow paper?
It is on your yellow paper, but I think I gave you a better definition than this one. The definition I gave you is the math notes box definition, which I don't know if I even put in here. Aha! Right here. Rational, you should circle, underline, ratio. Rational numbers, and guys, I did not understand any of this stuff when I was your age, so that's why I try to make sure you guys do. That word was chosen for a reason. It wasn't just like, okay, let's make up a word. Purple zebra. Rational, in its root, says ratio. And a ratio is any comparison between numbers. A fraction, a semicolon, the word two. Like when you say a ratio like 3 to 5, like T-O, not T-W-O, but T-O. Any of those create ratios. So any number, and I think I caught all the typos. Actually, I didn't catch them. I don't know, maybe I did. Any ratio, any fraction is a rational number. So any number that can be written as a fraction, like 7. Can I write 7 as a fraction? You bet you can. Just put it over a 1. Can I write negative 0.687 as a fraction? You bet you can. Just put it over 1,000. Can I write square root of 25 as a rational number?
Yeah.
Sure, because I know that is actually 5, and 5 can be written as 5 over 1. Ah, we're getting there. So, other examples are right here. Now, irrational numbers. So, ir means not, so what do you think irrational means? Not ratio, right? They cannot be written as a ratio. So, those Jenny method ugly square roots or non-perfect square roots, I guess non-perfect is nicer than saying ugly, but any non-perfect square root is an irrational number. In your calculator, hit the square root symbol, 3, hit enter. Avi, did you follow step 2 and get a calculator today? There's more back there. Excuses. I'm just giving you a hard time. Your calculator's dumb. I will say this over and over again. Your calculator is dumb. It shouldn't be spitting out domain error. I'll come look at that. It is going to make it look like your number has an end. That is a lie. That's the calculator rounding it. Because you did answer. You did any root. Guys, please make sure you're hitting the square root. It is the second of the x squared button. So that squares something. If you hit second that, it puts square root. You don't want anything to be coming before that. So square root 3, and then you hit enter. Yeah, now you need to go to mode and go back to classic. So now square root 3, enter. It looks like it ends. It truly doesn't. So your calculator is lying to you when you type that in. It spits out 1.7320, but I think it right at this 7 rounds it up to an 8. That's not true. So, I am here to say, if you believe me, if it's not a perfect square, it's irrational. But that's still real. Okay, that is still real. I'm on pen, not highlighter. They are still, both of these are real numbers. Okay? I'm not going to talk about non-real numbers till a little later, so we can get this imprinted into our brain. But real numbers are split into rational, irrational. The question is, can we write it as a fraction? And if the decimal keeps going on, you can't. So if you did not see this, it does not repeat. That's the biggest thing. Does not repeat, does not terminate. So rational numbers are allowed to repeat. So please make a note of that. I would put a star or underline that or something. Rational numbers can be repeating decimals. I'd like you to write down a couple examples. Yeah, but let's write down one that's more fun than that, like 2/9. Or actually, if I want to try to be funny, let's not do 1/3. Let's do 3/9 instead. So Simon wanted me to do 1/3. I'm just being annoying and saying let's do 3/9 instead. But remember, 3/9 is 0.3 repeating. This goes on forever. But any repeated decimal number we can write as a fraction. Your default is whatever repeats. Put it over that many nines. So remember, we looked at a bunch of special fractions and repeating decimals. This is technically 1/7. That is the fraction 1/7. However, I hate you. Actually, I like the new smart board, but no. Go away.
Die in a hole.
What fraction is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of 9 would be it?
Guys, this is the same as that. 1/7 is the reduced fraction of this. Your default is whatever. You might want to write this down. Like, I don't really like playing that you have to, because you don't care when I make you write it down. But the default, how to take a repeating decimal and make it into a fraction, is however many digits it's repeating. 1, 2, 3, 4, 5, 6. We put our number over that many nines. And if you type this into your fraction, if you type that fraction into your calculator and get it to reduce for you, that's a 7.
But why? Why not?
Because division by 9 never stops. Unless it's 9 divided by 9, and then that breaks the rule. But literally, no other division by 9 can stop. Like 1/9, 2/9, 3/9, all of them keep repeating forever.
So close.
If you go back to the days of long division, that was one where your teacher would, like, if they messed with you, they would see how long it would take for a student to be like, but wait, this isn't gonna stop. If you remember back to the days of long division, when we maybe, it depends on who your teacher was, taught you how to do that.
Depending on whether your teacher
Was a boomer?
is a bit.
All right.
Then they die.
So go ahead, and your graph paper should be on top of your yellow paper now, or your yellow paper can be put away. But we are not using that anymore today. When we look at doing the square root of numbers, certain numbers can be square rooted, certain numbers can't. And until we get comfortable with these, we most often just grab a calculator. But you should start to get in this, like, oh yeah, I remember that one. And 100 is one that we should already remember. What number times itself equals 100? Yeah, 10. So, stop it. Does anybody else see the fight I'm having right now? Okay, there we go. Just do an uppercut arm. No? I don't know how to do what you're telling me to do. Type this in your calculator. Let's see if we can do that. What if that was 625? Can you think of a number? 25, right? We talked about this yesterday. So instead of 25, this actually comes out to be 2.5. So even though that's a decimal, does this terminate or repeat? Yeah, it terminates. So that is a rational number. I could write that as 2.5 over 1 But guys, that is not appropriate. We don't do that. Like, that's right, quote unquote, but it's not the appropriate way to write it. We would write it as 25 tenths, or we could reduce
So then what's 62 points are?
We could do 5/2. That is the rational form of this number. So please, on your paper, I feel like I only half have you, write down that radical 6.25 is equal to 5/2.
What question is this?
What didn't work? That's 100. Question 100, Henry.
I have another question.
Hold on. Oh, dude, you're not using the square root button. You're using the wrong root button. You're using the X root. Any root. Now, here is actually why. The 6.25 and the 5 halves? Yeah. That's what we're about to talk about. All right, Patrick just asked, is there a reason that these are connected? 6.25. As I've said many times this year, I'm not really a big fan of decimals, unless like money normally has to be in decimals. But I would really write this as 6 1/4. But I'm also not a fan of mixed numbers. Guys, those of you who are only half with me that think like there's not much to learn, please realize I do have some stuff to teach you. So this is one of those things you've probably never seen this before unless you've gone through like 8th grade math on your own, like Khan Academy or something. So mixed numbers, meh. What's better than mixed numbers? Impropers, right? So this is really 25/4. Who can figure out the connection? Charlie?
It's divided by 2. Square root. Yeah.
What do you mean?
On both top and bottom.
Fair. I'm not talking to you. When you raise your hand doesn't mean you get the floor. Charlie raised his hand. I called on him. I'm talking with him. What do you mean it's divided by 2?
So you divide the top by 2. Because
Divide by 2. Hazel.
radical thingy.
Radical thingy. Give me more.
If you radical thingy 4 and 25.
If we radical the 25, what's square root of 25?
5.
And if you radical the 4, when we square root, or radical, but square root is the operation, a fraction, we break it up and square root the numerator and square root the denominator. So if those are perfect squares, I don't need a calculator for this. 6.25 is 6 1/4, which is 25/4, which are both perfect squares. So I break the square root to top and bottom, and I apply it. Just like when we apply a power to a fraction, it applies to both the top and the bottom. When I apply a square root to a fraction, it applies to both the top and the bottom.
Is there a way to know from the start if the whole number is going to come out to have perfect square roots of the numerator?
Think it through is really like the only advice I really have is like think through what would this be as an improper fraction. Now, when we have a calculator, you can of course just grab the calculator and use it, but this is the thinking, like the process that I want your brain going through. So if we go back up to radical 7, I'm really getting mad at you, smartboard. Type radical 7 into your calculator. What's that come out to be? Yeah, not a good one, right? So this, because it comes out to be 2.6. What is 7? No. So, hold up. So Simon was saying, wait, can we just like put it into the fraction form and do square root 7 over 1? Well, yeah, neither of those are perfect squares. But think about equivalent fractions. Well, 14 and 2, no. 21 and 3, no. 28, no. Like, there's no perfect squares that work until we get up to like
7 times 7.
but we could do, but then it'd be 49 over 7, which still, the bottom is still going to be radical 7. It doesn't work. This is irrational. That's what it taught. It doesn't come out nice, doesn't terminate, doesn't repeat. It's irrational. It's real, but you might want to make a note on your paper. This is irrational because it does not repeat, it does not terminate.
It's also just irrational to write the whole thing,
Irrational.
How do you know in the calculator if it repeats or if it doesn't repeat?
Pretty much if it takes up the whole screen and you don't see a repetition starting, it doesn't. Now you could use a bigger screen calculator or like a computer or something if you want more accuracy. So like type in 1 divided by 7 right now. Hit enter. You will see 1428571442 and you see the repetition starting. You see the repetition starting. So that's where also you just need to build some familiarity of knowing which numbers do and don't. And I'm here to tell you, if it's not a perfect square, it's not a perfect square. So here's the thing. Here's the thing that I want to make sure I didn't miscommunicate. I say the phrase here's the thing a lot. There's a lot of things. This, I think, when you guys look at 6.25, you think, oh, that's not a perfect square. Yes, it is. It is 625. And 625 is a perfect square. It's just been divided by 100. So they took 625 over 100. Both of these are perfect squares. That's why A worked out. They are truly, actually perfect squares.
I
10 wouldn't work.
I had him do math for me. Anyway,
Yeah, if you square root both.
if it was 625 divided by 10 or 62.5, it wouldn't work. It'd be a
Correct.
number. But why?
Because you haven't gone to a perfect square on bottom. If you do 62.5, it'd be 62.5 over 10, and we can't square root 10. Does that make sense? Like, look, this works because both are perfect squares. So this comes out to be 25 over 10, which is our answer.
Wait, but how did you get
Because literally 6.25 is 625 divided by 100. Like, that is literally the same number. Just put into improper fraction form. Improper fractions. I should have maybe done that one before I did the 5. We got to do more because I don't believe we could do this on our own. Talk with your team. Which of these would be irrational? Take a minute, maybe 90 seconds. Oh no, it could be more than one. I'm not saying one of them, just which. Like which ones? Oh, you had another question. What's up? No, none of those are. Which ones do you think are imaginary? Let me guess, the negative radical 15. So, the reason that wouldn't be imaginary. Do you want to explain to him why when the negative is in that it makes it imaginary? I don't know. Like, I think he knows a bit about imaginary. We'll talk about it in a couple minutes, but if you are able to explain it to him. This is a perfect opportunity for random cards. Random cards. Crystal, can you give me one example of an irrational cube? Yo, bring it back. That was 75 seconds. It was more than I promised. Crystal, give me one irrational. Ooh! Now that's one I thought people were going to have issues with. Crystal says pi squared is irrational. Why? Ooh. Now this one, I don't know. And yes, I'm doing the Mr. Kabilo, I don't know. But I'm not going to answer that today. So Crystal is completely true. Pi is irrational. And I used to have pi hanging up around the classroom, but it always falls down because it's way too wide of a poster. So it's hanging back there behind KDN. But literally, it goes on forever, doesn't repeat, doesn't terminate. But pi squared. Somebody type pi squared in your calculator. See what it spits out.
It's 869604401.
You said 6, 9.
Oh,
Does it look like it repeats or terminates?
Terminates.
No. If we take a non-repeating, non-terminating number and square it, would it? So wait, hold on. So can we say an irrational number squared stays irrational?
I think so because
No.
because all the numbers are squared.
Fair.
The square root of 7, that's never ending number, but if you times it by itself, it is 7.
So wait, you're saying square root of 7 is irrational, right? We're finding the we're not that. We're finding irrational numbers. But then you said if I do square root 7, why does it? I wonder if I can disable that. Square root 7 times itself. Wait, what's that come out to be?
7.
It's 7. So wait. Can we then, and Crystal, this is kind of a question for you to mull on too. Should irrational numbers squared become rational, right? This irrational number squared became rational.
Not all of them.
Or maybe there's just no rule. Hey, I yelled at Bear when he didn't raise his hand and he just took over class, and I'll do the same thing. Raise your hand if you want to give something out. Otherwise you're just it's chaos, right? It turns into chaos. This is a great time for me to remind people there aren't always rules, right? Don't try to invent rules when there may or may not be. Alex? Well, if you do square root 76 times itself, it always perfect square root. Okay, I'm getting tangled up. Let me ask you this: is square root 76 rational or irrational?
Oh, wait, I knew I was thinking.
I mean, is it rational or irrational? Is it a perfect square? Square root 76, is it perfect? No, because 64 is, and then the next one is 81. So square root 76 on its own is irrational. But I had somebody over here threw out any square root squared will be that thing, the original thing. Because they're inverse operations. What else up here? Mr. Dale, what else you got? Other irrationals? Negative square root 15, because square root 16 is rational, but not square root 15. What about this scientific notation? Avi, what's your thoughts on that?
It's rational because the 10 squared, or 10 negative 2 squared is, 100, and that is going to be negative 640.
Remember, a negative power puts that thing in the denominator. So 10 with the negative power of 2 actually takes a trip to the denominator, and then the power becomes positive. So this scientific notation is literally this number in rational form. Rational form just means make it a fraction. So if a problem asks you to write this in its rational form, just make it a fraction. Doesn't even have to be simplified. Just make it a fraction. Henry?
So, does square rooting a number function like parentheses in order of operations?
Give me 2 seconds to finish this, and then we'll talk about square roots. This one, I don't want people to fall into a trap. 730 divided by 99 does not repeat 73. It kind of does. 730 over 999 is really 0.99. So in your calculator, type in 730 divided by 99. It's missing a 9 on bottom, right? Because we're supposed to have 3 9s if there's 3 numbers. So what does this repeat?
Oh, no, it's 7.
So wait, is it 0.0 or point?
So once you get to
Oh wait, it's more. It's more than 1, right?
3737.
So you said it's 7 point.
Yep.
Is there a 0?
No.
So it's 7.3737.
Yeah.
No, they're right.
Remember that 4 at the end is a lie.
Yeah, it's
Can anyone tell me why? Alex? Well, yeah, but not why the 4 is a lie. Why it repeats 37 here.
because it's, well, I'm just making observations that are concrete. Oh.
I think Simon beat you on that one. Simon?
So like with the scientific notation, the zeros don't matter unless they're holding a digit place forward.
No. So 730 is bigger than 99, so it's gonna be over 1. So there has to be something in the ones place. That's 7, and it goes on from there.
Come on, guys. In mixed form.
Pretty funny.
That's improper like crazy. Right? In mixed form, it is 7, and 37 over 99. Now I've just got 2 digits over the 2 9s. That's what repeats. If you have improper over a set of 9s, make it proper. Then you can figure out what repeats. Now, if it's not, but if this was 07, this would be 7.070707, meaning, this is the trapdoor I want to hope we all avoid, if there's not the same number of digits, the eyes not looking at me will not know this on the test, make the same number of digits. Make it have zeros in front of it to equalize out the amount of digits. So to go back to something we talked about way back in the fall, if I gave you 125 over 99,999, well, how many zeros should I add out here? 2. So then this becomes 0.00125, 00125. The zeros will also repeat, because it repeats however many digits there are 9s.
But how do we know that it's not like 0 0? How do we know that it's not like 0 1 2 5?
Because math, do the long division.
Well, how do we know it's not like 25 0 0 1?
Because, dude, that value wouldn't make sense to be an equivalent value. If it's 0.2500125, that's a fourth. Right, 0.25 is a fourth. That's nowhere close to a fourth. It's 125 out of 99,000. You know what I mean? It's just the math behind it. We have to have these missing places, not really missing, but these zero placeholders to actually get to a quantifiable amount left. Does that make sense?
Yeah.
Like, I know you're trying to equate the rule, just like the straight up rule of digits repeating, but what the rule is our digit, we have to have the same amount of digits, and then those zeros take that placeholder position. Cool? Maybe. We'll keep doing more with this. This is a really silly slide. Because here's the questions I asked. Bianca, what would I write to show the rational form of this number?
90 out of 100.
Oh my god.
Did we not hear me say Bianca? Now I understand why I got in trouble for doing that when I was in school. My teachers would seriously, like, that's what they would tell me at conferences. Would you like to do one of those, Skip? Logan, how do we put this in rational form?
391 out of 1,000.
391 over 1,000. Can we skip past this slide?
No, we don't understand it.
Alright, how do I write this? Yes, I know, I missed a zero. Ike, how do I write this?
I think it's 1 over 1,000. Are you sure? Yeah, I'm not quite sure.
Xander, what about this one?
524 over 1,000.
No way!
I'm moving on.
Yay! Now we have a chance at lunchtime.
Oh no, this lesson 2. This is gonna be a 2-day lesson. So, oh yeah, to alleviate any fear/concerns. I know yesterday's homework was a bit bigger and today's homework is a bit bigger. Tomorrow we're gonna finish this lesson and have no new homework. So tomorrow's like your catch-up day for homework. So take a couple of the problems from Monday and a couple of the problems from today and tell yourself that's Wednesday's homework. But you should get stuff done. So this, if you want to prove, did we not do the proof of why repeating decimals are repeating decimals? Of like 100x minus an x. Okay, so real quick to talk about why this exists. This might be mind-blowing for why this works, and Simon, you might appreciate this. So 5, 7, 5, 7, 5, 7, it repeats forever, right? So you put a repetend over it, whatever. You start working with this number, and you really, really, really want to represent it as a fraction. So x is going to be the fraction that we want. Now to start, we just have a portion of a value, and you're like, well, that's kind of poo-poo. I'd rather start with a number on the left-hand side of the decimal. So according to algebra, you can do anything. So you multiply by 100. Yeah. Go ahead and write this down real quick. Write this down.
Write down 5. Write that down.
Wait, in our calculator or in our paper?
On your paper.
It's not rocket science.
As long as you do it on both sides.
It is math.
So to get some numbers on the left-hand side of the decimal, and guys, this is definitely one of those moments where I didn't know how to do this till literally 2 years ago. So Bear and Liam, I would appreciate if you would respect me teaching up here and actually come along with me on this proof, unless you can tell me how to solve this. We need to prove why this is going to be 57 over 99, right? Because you go home and you're like, well, that's the rule. And your parents are like, rules are silly. Show me why. So when we do this multiplication, we get 57.57 repeating forever equals 100x. Do you know what I'm going to do next? I'll be very surprised if you do.
I know how to get it. I know why it is. Kind of.
So do you know what I should do next in the proof?
Oh.
copy. In a way. We would like to get rid of this nonsense, right? The 0.57 repeating. And we know that 0.57 repeating is x. So we take away 0.57 repeating, which takes away an x. That leaves us with 57 equals 99x. How do you isolate x? Divide by 99. And that tells us I am really frustrated at that, seriously. And the fraction form of that decimal is 57 over 99. That is legitimately the proof of why. And you can do that with any number. Take away an x. There you go. Alright, later guys. Have a great day. Thank you very much. As long as you follow the rules. We could probably make a math problem to show how you could fly. Like the force needed, the wing size, like what you would need to attach to your arm, how quick you would need to flap your arms.
You just take it